Part 4, and what we're going to talk about is we're going to talk about the norm functions. So in R, there are lots of norm functions, right? Norm meaning things that fit a normal distribution, and this tutorial is going to teach us how to use them. So in Project 3, you did have to, oh no, it was Project 2. In Project 2, maybe it was 3 actually. Okay, in Project 3, you've seen R norm, right? What that did was that would randomly generate variables that fit a normal distribution with a mean of whatever you set it equal to, the default 0, and a standard deviation of whatever you set it to. Right now, the default's 1, right? But there are more normal functions. So let's take a look. If I type in $R norm, we can see we find more. There's also D norm, P norm, and Q norm, and we're going to talk about those as we go through this little bonus tutorial. Not really meant for a project, but very helpful. So the first thing I'm going to do is I'm going to create a variable x1, and I'm going to store 100 randomly generated, normally distributed variables with a mean of 0 and a standard deviation of 1 there, right? So then I can make a histogram of this. Notice I typed frequency was false, so it's a density histogram, right? Here's my lovely distribution. And what is interesting is every time I run this, it's going to change my graph because it changes the variables. I can also calculate the mean. The mean is 0.013, so again, very close to 0, and our standard deviation is 1. But I want to make sure we can see this histogram. I don't need that. Okay, so we've got our histogram, but there are 3 more norm functions that we need to discuss, and I'm hoping this visual will help you get a better understanding of what D norm, P norm, and Q norm do. And again, this is a RMD file, so it's an R Markdown file, so it's going to give you a PDF, which makes this a little bit easier to read. But we have 3 norm functions to discuss. So here's our visual for that. So here's our density, our x values, right? D norm gives you the density of that variable. P norm gives you the probability. So 0 is our mean. Our mean divides things in half, right? So the P norm, the probability up to 0, right, of getting something less than 0, otherwise known as like our Z table, that's 0.5. And our Q norm takes that probability and spits out an X value. So it's kind of like undoing the whole Z table, Z score to Z table process, right? And that's helpful, right? Because we don't always have a Z table available to us. And I'll be doing another tutorial where we solve a bunch of functions, a bunch of questions using P norm and Q norm. D norm isn't as useful, so I'm going to touch on that like briefly. So D norm gives you the density for a specific value in a normal distribution. So let's go ahead and create a larger randomly generated data set. Let's call it x2, because it will approximate a normal curve the larger we get. So we can visualize how the density function works. So there I have created a data set with 10,000 variables that are normally distributed. Here's my beautiful histogram. So let's go ahead and calculate D norm of 0. Oh no, where did it go? Okay, let's try this again. Let's run all this. Okay, so here's my histogram. Here's my console, so I was saying 0. I ran D norm of 0. 0 is 3.9. We could kind of see that, right? That it's about 3.90. Now this is if this was like a perfect normal distribution. I also ran D norm of -4. We could see that that's 0. Let's take a look. Oh yeah, -4 has got nothing going on. And then I did run D norm of 2 to figure out what the density was, and I got 0.05. So let's see if that works. Yeah, I think right here, 2.05, it's just about that. Now note, this is not a perfect normal distribution, but I just wanted you to kind of visualize what D norm did. Next is p-norm. So this is the probability, area, cumulative relative frequency, the left of the value, i.e. it's a z-table. So we can compare z-table out values to the output of this function. So because our means are 0 and 1, the p-norm of 0, right, is going to be 0.50, right? We would have found that in our z-table. Same thing for 3, right? If I'm 3 standard deviations above the mean, we've got 0.98. P-norm, we've got 0.156. So you could look up these z-table values. Note, it's going to change when we have a different mean and a different standard deviation, and that's what I think tutorial 5 is going to be all about. So I know you're looking forward to that. Q-norm is the inverse z-table. So your input has to be a probability, cumulative relative frequency, percentage, and it's going to give you back your x value. Note, that means I'm pretty sure if I put in a number like 5, I broke it, right? Because that input has to be a probability. It has to be a number less than 1. A number less than 1. Again, math professor, that's what I am. Not a great typer, not a great speller. But we can kind of see if we look at what we ran before for p-norm, q-norm is going to undo it. So if I take q-norm of 0.05, you bet I'm going to get 0. If I take q-norm of 0.9986, there we go, I get 3. And if I take q-norm of 0.158, again, I get -1. Note, this is when the mean is 0 and our standard deviation is 1. We can still do this, but we would have to define a new mean and a new standard deviation in order to get our values to change. And that's going to be the highlight of tutorial 5. Remember to comment with any questions.